Hey science maniacs, welcome to SciTech Experiments Quarantine Edition. I have with me two Ramsey graduates that are going to help us do an experiment today about acids and bases. It's Aiden, Logan.
Hi.
There we go.
Sup?
So today we're going to be talking about chemistry, and we're going to be talking about how do we know if something is acidic or not. So all substances have some sort of pH, and that tells you how much of an acid or how much of a base a substance is. And we measure it on what's called a pH scale. A pH scale runs from 0 to 14. If you are a strong acid, you're closer to the 0 side. If you are a strong base, you're closer to the 14. And if you're not an acid or a base, you're right in the middle, which is 7. So we don't want to have anything that's too strong of an acid or too strong of a base because it's not good for us. But some things have a very strong acidic content, like your stomach acid or lemon juice. Yeah. And then some things are very strong bases, like Clorox, and a lot of types of milk are strong bases. So there is a substance that covers 3/4 of the earth and makes up most of our body that is right in the middle, neutral. Aiden, what is that?
Water.
It is water. So water is neutral. It's close to 7, right around 7, and it's very important that it's neutral. It keeps everything in balance. So we're going to do an experiment today to see if we can determine if something is an acid or not. And what we're going to be experimenting with is something that we breathe out. Logan, what kind of gas do we breathe out?
Carbon dioxide.
Carbon dioxide. So even though it's a gas, we're going to measure if it's an acid or if it's in a base. And we're going to do that with the help of chemistry. So what I have here with my two assistants, we have 2 beakers of our neutral substance. What is that?
Beakers of our neutral substance?
Yeah, what's the neutral substance that's a pH of 7?
Water.
That's right, water. So this is spring water, so it has a fairly neutral pH. You want to have pure water. Tap water has other stuff in it, which will mess up the experiment some. And then we have what we call a pH indicator. This is a chemical, unless you have a scientist in the house, you probably won't have this on hand. It's called bromothymol blue. And this bromothymol blue changes colors in the presence of an acid. So what we're going to do is add several droppers full of this bromothymol blue into our water. There we go. Bromothymol blue is actually kind of green looking today. All right, so let's take a closer look at these bottles. So we've added it to our water, and it's really dark colored. You can't really see through it. We're going to mix it up a little bit. Now, how do you think we're going to get the carbon dioxide into our bromothymol blue mixture?
We're gonna breathe it out with a straw.
Yep, we're going to use straws. And you know how I always say you're not supposed to make bubbles in your drink?
Yeah?
Yeah, we're going to make bubbles in our drink today. But one thing you need to know, do not drink it. This is going to be dangerous if you drink it. So do not drink it.
Yeah. Got it. You breathe out, not breathe in.
Exactly. Breathe out, not breathe in. So let's set this up so that everybody can see it a little bit better. And then you guys can stand up, grab a straw.
Okay, I took my thing out.
Yes. All right, come over here, Aiden.
Where can I place it?
Just hold on to it. Come over here, Aiden, so your brother can get in.
Hi.
There you go. Now, Logan, you get right here. All right, put your straws in. Don't breathe in just yet. Or breathe out, I should say. Now, remember, you're not drinking it. You're breathing into it, making bubbles. And don't do it too hard. You don't want to splash. We have safety bottles going here so it doesn't splash back easy. All right? So go ahead and start gently breathing into it. Keep going. And we already see color change happening. Look. Look at what color your solution is now.
It's orange.
It's orange, yeah. All right, very good. Let's take a look. So that's the color we ended up with, like a really bold orange color. So this occurred because carbon dioxide that we breathe out is actually an acid. So the bromomethyl blue showed that it's an acid by changing colors. And this is an important thing to know, because have you ever heard of acid rain?
Maybe.
So acid rain happens when there's pollution in the rain. And it makes it a little bit of an acid. Not dangerous, like it's not going to burn us if we walk outside in the rain. But what happens is there's too much carbon dioxide in the atmosphere, and it mixes with the clouds, and then it makes the rain a little bit of an acid. So that's why we can see that carbon dioxide is acidic from our breath. And that's why we got to make sure there's not too much carbon dioxide in the atmosphere, because that can really mess up our water. Water needs to stay about 7, otherwise it's going to mess up a lot of living creatures, right?
Yeah.
Yeah. So we need to make sure not to have too many of those greenhouse gases. So what we can do now is go around and look in our houses and see if we can think about what types of things are acids and what types of things are bases. You can research this. There's a lot of things around your house that you can find that are acids and bases, like a lot of your fruits that you like, Logan. They're very acidic, so they would be acids. And maybe we can experiment more on this and see if maybe having an acidic fruit causes more of an electrical charge when we make batteries with lemons. You've done that before, right, Aiden?
Not with lemons.
What'd you use?
A circuit with wires, tape, and a light bulb.
So what if instead of a battery, we could use fruit? Should we try it?
Sure.
Okay, we should try that again. We have to go home and get some fruit, and we're going to try it out. Thank you for watching. Hope you guys are doing good. Bye.
Bye. Adios. Bye. Have a good time.